Hey there, as Evalds Associate Professor, Researcher, Founder. So I just want to share another quick tip on ChatGPT. I'm doing these small videos, so please check out others as well. So let's move in. So here's the Facebook ads campaign results in Excel sheet. And I want to show you that ChatGPT 4.0 is a super powerful tool to replace the analysts for data, and you just need a little bit of knowledge, but you don't need to know how to program or do other things. So here's the performance of some kind of Facebook ads. Like there are some markers: age, gender, interest groups, the clicks, spent money, total conversion, and approved conversion. And we should then make a sense of it, which campaigns were the best and why, right? So kind of common task, and how you would do this very quickly with ChatGPT, not spending lots of hours. So GPT 4.0 is very good at translating human language into programming language. So this is the kind of new way how to operate with the computers. You don't need know lots of computer languages, you just need to understand what you're doing. So let's start by showing how not to do it, not to do this. So the way how not to do this would be the simple dummy way, how everybody would do this. Just copy in the CSV file, the Excel file, right? It's better to export it in CSV format, it's simpler. And then you would type in which campaign was the best and why. So, and you would imagine that this is some kind of super AI which will resolve all of your issues, but this is not the best way. But still, let's try it. To give that good of insight. So it said that campaign is the best overall, and not many kind of other insights here. The reasoning also is not that great, and if you look in the way how it made the code, even though you don't understand it, maybe it's not very complicated, it's not very smart way of analyzing data, so you don't expect any good results by doing this. But let me show you the best way how to do this. So you would just drop in the same file and would direct the ChatGPT to generate small pieces of code which it will execute itself step by step. And you need a little bit of knowledge of what is like data processing in general, but you don't need to know how to program, and you can get the results yourself. So let's look at what we have here. So first of all, maybe we should clean out columns which don't give us much of value. So one way would be describe columns. There is actually one small function which is useful. It's called describe, and it's in the Python NumPy, but we don't care about that. So it will describe what is inside each of the columns. You could also ask, the min max values and so on, but maybe for starters this is enough. And we immediately see that we need to remove a couple of columns. Like, we definitely don't want to correlate our performance of ads by just unique identifier of ad, or there is duplicate columns like Facebook campaign ad, and reporting periods also is not something that we are interested in. So we will write then remove columns, ad ID, reporting start, reporting end, Facebook campaign. And there is a cool trick. You always ask to save as CSV, because then if you ask to save as CSV, you can download every step of the way the results and verify them. And basically, you should never trust it as face value. Just go step by step and get to the result faster. So we'll do this again. So it says it's ready. We could double check it in Excel. Then there are the spent amount of money spent on ads. I know that there are some records which have 0 spent on ads, so then we can ask remove rows where spent equals 0, save as CSV. You see, I'm asking this in natural language, not in programming language, but the same way it's not as human as you might think, because every time when I ask something like this, it generates a bunch of code here and then executes it. And basically, that's what programmers do. The programmers know how to write the code, but you can now write code with natural language. Next, I would ask to calculate return of investment, which is the approved conversion rate divided by spent money on each of the ads for each of the person seeing the ad. So, and save as CSV. This would mean that basically where the value is higher, it would be better results. You can imagine that if there is a approved conversion, that's 1, if not approved, that's 0, and then divided by how much money spent. So the less money you spend, the higher the value. So that's what we have here. Then what we want to do is plot total spent average return of investment by campaign ID. So these column names, very important that you track the column names. It's the same column name for the campaign ID. And now I created this new return of investment column here by asking calculate this thing and then downloading the CSV. I can verify that and display as bar charts and x-axis campaign ID, hopefully right. So the other keyword, plot, right? So remove, calculate, plot. What else we've had? Describe. So some of the keywords. You don't need to know that much. So then let's plot them. So you see these nice charts. So first of all, we see the campaign ID 1178, and then here is the 936. So there is the total money spent for each campaign. You see a lot of campaigns have very little money spent, and some are significant. And then also the return of the investment. We see that the one where we spent a lot of money, we have some in return. So we should remove those which we don't have lots of spent money and no good results. So how to do that is list unique campaign IDs. You could just ask campaign ID. Actually, IDs would make it a little bit hard for the model, but still remove campaign ID from the columns, right? From the rows, I mean. So these, we just will leave those that are meaningful. So that's that. Then we can ask again to plot the same chart just to verify that we're on the good start. So when it's saying that it's analyzing, it's generating the code and then executing for it. So now you see that the total spent money, right, and the campaigns here. In general, we could just compare the 936 with 1178 because they have some significant money spent, and this one has a very little budget, right? We could do that, or we can just look at some other ways how to filter out data. So another keyword is plot, which I mentioned already. And if you know anything about the data processing, you might know that there is principal component analysis, the way to reduce dimensions for the data set and visualize it. So you can take this kind of prompt, plot PCA colored by campaign ID. So now what this means is that by the other features, not the campaign ID itself, these are the similar groups of the ad impressions. So the orange ones, green ones, and blue ones, and already we see that there are some similarities between them. And this is like abstract space. The PCA, PCA1, PCA2 does not mean the real values. It just means what is similar between all of your records in your data points, because here we can see in the top part there is actually one cluster of similar interactions with your ads here. You could go and research that part deeper if you want, but let's do some very simple things. So I will ask to calculate centroids for each of the PCA campaign IDs, and then plot them along with the other data points. So now I see that all of the data points around here are the green ones are this 1178, and other ones are here. So and then the normal processing for data would be to delete outliners like this guy here on the very right. This is something that we should delete so that we don't mess up our assumption for our data, right? So then we add delete outliner rows based on PCA distance from centroids. And then we can again plot the same data just to verify that now it looks a little bit different. So now we see that the scale has changed. Here we had the million PCA scale, and now we are on the 500,000. So and the data points are much more dense here. So this is much more cleaner data set already. So as soon as we have cleaned up our data set in very, very simple manner, there are many other ways how we can clean out outliners of the data set. I can share that in other videos. Then we should start asking the questions that matter. So what is, for example, common for campaign 916 and 936 versus 1178 in terms of average age, gender, interest 1, interest 2, interest 3. So we are limiting everything. So this would be very similar what you would do in computer programming, but you are programming now computer with your own language, and anyone can do this as long as they understand what they're doing step by step, instead of thinking that this is an oracle that will do everything for you. So it's listing the similarities between both groups. So the first group, the second group, and then points out to the things which are most different here. So the average age of all groups is about the same. So that's a good data point, because there were other age groups also. So it seems that there is the gender, some kind of majority. So this one, which performed better, was targeted more towards males. Plus also there are some differences in the interest factors. So, and then you can look up which exactly the interest factors are the ones that are more different to these groups. And then you can adjust your targeting to make targeting work better. So then next question obviously would be what is in common in terms of average same columns for rows where approved conversion is larger than 0 and where it's 0. So in terms of where the campaign worked and where the campaign didn't work. Again, we have cleaned data set. That's why this will work much better than trying to do this from very scratch. So we see that both groups are kind of similar, and basically the main difference then lies into the previous analytics, where we had these factors which determine different types of campaigns rather than something that's common to all of the campaigns. So this is a good information. By using this, you can immediately start targeting better your audience, and basically you don't need data analysts anymore.